see our first problem and try to solve this problem using the concept that we have seen in the last class. So let's mark this as question number 1, and here we can assign any dimension. Let's attribute some dimension to these sides as well. So I have drawn this scale as 20 mm. Here it will be your 100 mm, 100, and again this height is your 80 and this breadth is 20. So these are the dimensions that we are going to use to find out the locations of centroid, and remember all dimensions are in mm. So let's try to solve it. So first thing is drawing the reference axis and checking for the axis of symmetricity. So as we have discussed, axis of reference will always pass through, unless it is not given, always pass through the extreme edges of the geometry. So this is going to be my y-axis and this is going to be my x-axis. So x and y coordinates has been assigned, the reference axis has been assigned, and the second thing is to check for the axis of symmetricity. Now remember, axis of symmetricity is that axis about which if the object is folded or cut, each side is going to overlap with each side, means all the sides, left side and right side, or either top and bottom side is going to coincide with the other section. So here we can see that we have found an axis of symmetricity for this geometry, which is right. Now the left side is definitely going to coincide with the right hand side or vice versa. So in this case, my centroid is going to lie, for x-axis it is going to lie on this particular axis. So here this distance, if the entire length is 100, this distance has got to be your 50 mm, and this is the location of your x bar. So we have found out without using pen and pencil, without just using the concept of axis of symmetricity, we found out the location of x bar. But now in y bar we cannot find out the axis of symmetricity, and that is why we need to calculate it. And the process is very simple. We have discussed it. Make the table. So how many geometries are there? Geometry 1, let's mark it 1, and let's mark it 2. So geometry 1 and geometry 2. So two geometries are there. So number of rows will be 3. 1, 2, and 3. So first column is geometry number 1 and 2, and the second one is area. Since the dimension is in mm, the area will be mm square. And third one is your x. We are not trying to find out, so we are only dealing with yi, and the unit will be mm. So this is the table. Since x we have already found out using the concept of axis of symmetricity, we need not to find it for xi and x1 and x2. Now first thing is, let's talk about the area of geometry 1. So geometry 1 is this bottom rectangle with a height of 80 mm and the width of 20 mm. So the entire value is 80 into 20, which is equal to 1600 mm square, and area 2 is of breadth 100 mm and depth 20 mm. So the area is 100 into 20, which is equal to 2000 mm square. Now let's try to find out yi, that is, in this case we are trying to find out y1. So y1 is equal to, in y direction, we see that the bottom part of the reference axis is in contact, bottom part of the geometry 1 is in contact with the reference axis. So, and it is symmetric about the vertical axis also. So for a rectangle in this portion, we have seen that it becomes the half of the height. So b by 2. So putting the values here, total height is 80, which is b, so b by 2 will be u. Y1 is b by 2 is equal to 80 by 2 is equal to 40. Now y2. So while dealing with y2, while dealing with area 1, we completely ignored area 2. So while dealing with area 2, remember you have to ignore area 1. So I'll try to delete this bottom section just for understanding. We have this only area 2. Remember the distance between this axis and the bottom edge is 80 mm. So first thing is find the location of the centroid within the geometry with reference to its extreme edge. So in this case, since my reference axis is bottom, I am selecting this edge. And we have seen that if it is symmetric, it will be half the distance. In the first video itself, it will be h by 2 given in the formula itself. So we are going to use this concept, which is h by 2. So height is 20. So it will be 20 by 2. And then from this point, and what will be the distance of this point with reference to this location? It will be 80 mm apart. So this distance will be added plus 80 will give you 90. So the very common mistake students make is they see that 80 plus 20, they divide it by 2. No, that's wrong. First, find out the location of the centroid within the geometry with reference to its own extreme edge, and then add the distance between that extreme edge and the reference axis. That is only how you can find out. So once you have able to do this, bringing our area 2 back, let's put the values in the formula. Y bar is equal to, now the areas are only added, so we are going to use the addition formula. So a1 y1 plus a2 y2 divided by a1 plus a2. Let's take the values from the table. A1 is 1600 and y1 is 40 plus a2 is 2000 and y2 is 90, not plus, multiplied by 90 divided by 1600 plus 2000, and this value will be your, let's put the values in the calculator to find out the answer. So it is 1600 into 40 plus 2000 into 90. So the numerator value is 244000 divided by 2000 plus 1600, 3600, and this value will come out to be plus 3, sorry, divided by 3600, 67.77. So this point is actually at a distance 67.77 from the bottom section of the geometry. So the entire height is 100, this is 80, I believe 67.77 will come at this particular point. So how to represent? So centroid is location, x bar we have found out by axis of symmetricity 50, y bar is 67.77, and what is the unit? M. And this is the answer, and this is how you represent the answer. Okay, so first check for symmetricity, that will help you save a lot of time, and then put the values in the formula to get the answer. Let me put unit here as well. So this is how you represent your answer. Don't forget to highlight it, and this is how you find out. So see you guys in the next video with another problem. That's all for this one.